Here we have a simple titration problem. The problem states a 75 milliliter solution of hydrogen chloride with an unknown concentration is titrated to the equivalence point with 27.3 milliliters of 0.157 molarity calcium hydroxide. What was the concentration of hydrogen chloride in the original solution? So first thing I'm going to do is just to underline my important parts of this problem to help us see what's really going on and make sure we don't miss anything. So here, 75 milliliter solution of hydrogen chloride. That gives us the volume of that solution. We do not know the concentration of the hydrogen chloride, and then it gives us 27.3 milliliters of 0.157 molarity calcium hydroxide. So volume, concentration of calcium hydroxide. Then I'm just going to underline what the question is really asking us to solve. So concentration of hydrogen chloride in the original solution. So the balance equation for this is as follows. This is essential to getting right because if you get it wrong, it's going to mess up the whole problem. So we can see that there are 2 hydrogen chloride moles, 1 mole of calcium hydroxide, and that yields 2 moles of water and 1 mole of calcium chloride. And to do this, we just have to make sure that each side is equal. So we have 4 hydrogens, 2 chlorines, 1 calcium, and then 2 oxygens and 2 oxygens. So that's right. Next thing I'm going to do is draw a picture so we can better understand what is going on in this problem. So here is the hydrogen chloride solution. We have the H plus ion and the Cl negative ion. We have the volume 75 milliliters, and right then I can see that it's in milliliters, and this problem it needs to be in liters, so I'm just going to change that right now to 0.075 liters. 0.075 liters, so I won't mess up later on and forget that. And again, we do not know the concentration. So then I'm going to go over to my calcium hydroxide solution, and here we have a Ca2 plus ion with 2 hydroxide ions. And we do have the volume, and again I'm going to change that to liters, and here we have the concentration, 0.157 molarity. So this solution is going to be poured into this, the hydrogen chloride, the calcium hydroxide will be poured into the hydrogen chloride, making a precipitate of water. That's why the OH and the H's are X'd out. So next I'm going to talk about what we know in this problem. So we do know the volume and concentration of calcium hydroxide. We can use this to find the moles of the calcium hydroxide, and then we can use the balance equation to find moles of hydrogen chloride. Once we have the moles of hydrogen chloride, we can then use the given volume to solve for the concentration. So as you should know, we have a simple equation, moles equals volume times concentration. So as I stated before, we can find the moles of calcium hydroxide, so that's what we're going to do. So here I set up an easy problem, volume times concentration, 0.0273 liters times 0.157 molarity. And that gives us 0.004281 moles of calcium hydroxide. So once we have the moles of this, the calcium hydroxide, we can solve for moles of hydrogen chloride by using the relationship in the balance equation, and this is known as stoichiometry. So for every 1 mole of calcium hydroxide, there are 2 moles of hydrogen chloride. So 0.004281 times 2 gives us 0.008722 moles of hydrogen chloride. So now we have the moles of hydrogen chloride. And again, we have the volume of hydrogen chloride. So I'm just going to use the moles equals volume times concentration equation again. And this time we're going to solve for concentration. So we have 0.0085722 moles of hydrogen chloride equals 0.075 liters times an unknown concentration. We need to get rid of the liters, so we are going to divide by 0.075 on both sides, and that is going to give us a concentration of 0.114296 molarity. And that is the answer to our original problem. Common mistakes in this problem can be not changing the milliliters to liters, getting the balance equation wrong, trying to use M1V1 equals M2V2. That is a problem for dilution, not titration. And then just forgetting that when we can find moles of one ingredient, we can use stoichiometry to find the moles of another ingredient.